in the history of derivatives. The derivative of e to the x. d dx of e to the x is e to the x. Now, be careful. If we wanted to take like d dx of e to the u, and u is a function, then it would be e to the u times du dx. Alright, so derivative of e to the x is e to the x. But if you've got e to the function, it's chain rule, right? Derivative of e to the function times the derivative of the function. Okay? So for example, if I wanted to find the derivative of y equals e to the x plus 2, this is a function, in a function, right? Composite of functions. Then we would say this, y prime equals e to the, well, the derivative of e to the x plus x squared, times the derivative of whatever is in the exponent, which is 1 plus 2x. And that's it. So, hopefully that's not a kind of mind-numbing concept. Following, f of x equals e to the 2x plus sine of e to the x. Alright, here we go. F prime of x. Derivative of e to the 2x first. Well, I know that that is e to the 2x times 2. Derivative of 2x is 2. Plus the derivative of sine of e to the x. Alright, well I think that that's going to be the derivative of the outside first. What's the derivative of sine? Cosine. So cosine, leave the inside alone, times the derivative of e to the x, which is just e to the x. Cool. And we might rewrite this as 2e to the 2x plus cosine e to the x. Actually, sorry, we should throw that e to the x out in front. Doesn't really matter, but e to the x, cosine x. A to the x. We would write this. d dx of a to the x is going to be a to the x times the natural log of whatever the base is, times the natural log of a. Okay? If I have a to the u, where u is some function, which will happen probably quite a lot, and I want to take d dx of that thing, then that's going to be a to the u times, once again, the natural log of the base times the derivative, whatever u is, right? du dx. So, y equals 2x minus 3. Well, the derivative of 3 is pretty easy. That's just 0, right? But the other one, y prime equals, alright, I think this is going to be 2x times the natural log of the base, natural log of 2, times the derivative of x. Well, that's just 1. So this time it happened to be a very simple function up in the exponent. Okay, minus 0. Right? So if we simplify this, well, we can't really simplify it that much, but 2 to the x times natural log 2. Natural log of 2 is just a constant, right? Constant. This d dx of natural log of x is pretty simple. It's 1 over x. That is pretty simple. Not as simple as e to the x, but pretty simple still. Noting also that if I have d dx of natural log of u, where u is some function, it's going to be 1 over u times, times du dx? Chain rule, right? Chain rule style.
Really?
Oh, really? Very much really. Okay, let's do this one. Find y prime if y equals 4 times the natural log of x cubed minus 5. Now 4 is a constant. We could do the product rule. I'm just going to leave it out in front. So y prime is going to be 4 times derivative of the natural log of x cubed minus 5. Are we okay? Is going to be 1 over x cubed minus 5 times the derivative of x cubed minus 5, which is 3x squared. Okay? And we could simplify this to make it a little bit nicer. Y prime equals, let's see, 12x squared over x cubed, x cubed minus 5.
Why did you do that?
All right, I want to find f prime of x, and I want to state its domain. Let's first find f prime of x. So real quick, f prime of x, remember that's 1 over u, which is x minus 3, times the derivative of the inside, which is 1. So my derivative is 1 over x minus 3. Right? The only restriction on the derivative is x cannot be 0. So if I'm thinking about the domain of the derivative, it's from negative infinity to infinity, except for when x equals 3. But wait, I can't differentiate where the function doesn't exist. I'll say that again. I cannot find the derivative where the function doesn't exist. So what is the restriction on the domain? What is the restriction on the domain of the original function? In other words, what is the domain of the original function? X has to be greater than what? Yeah, the domain on that is x greater than 3. So does it make sense that the derivative's domain can't be anything less than 3, or it has to be x greater than 3 also? Okay, so the domain of this has to be x greater than 3. And notice that we're okay because we're still not including, excuse me, we still don't have 3 included in that, right? X greater than 3 does not include 3. Okay? So be careful when you're looking for the domain of derivatives. So if I want the derivative of this, I'm going to have to use the product rule. Y prime equals the first, which is x, times the derivative of the second. 1 over x. Derivative of natural log of x is 1 over x. Plus the second, natural log of x, times the derivative of the first, which is 1. Is this another product rule? Oh, yuck. Minus the first, x squared, times the derivative of the second. Okay, derivative of e to the 2x. I think that that's e to the 2x
times 2.
Times 2.
Oh, yeah.
Oh, and I'm running out of space, but this is going to be plus
2x.
e to the 2x times 2x. E to the 2x times 2x.
Why did you do that?
Times negative 2x, right? Or no? Why are we separating?
Explain. What did you
Product rule?
just...
Yeah, whatever you want to call it. All right, let's simplify. I think x over x is just 1, right? So y prime is 1 plus natural log of x times 1. Well, I think that's just plus natural log of x. Minus x squared times e to the 2x times 2. No, nothing good's going to happen there. I think we'll just rewrite it as 2x squared times e to the 2x. Oops. Distributing the negative, right? So we're actually going to have a minus 2x e to the 2x. And I think that's it. That's as simple as it's going to get.